We ended the last lecture module with Goodman proposing his reflective equilibrium model for formulating and revising inference rules. This model is intended to apply to both deductive and inductive inference rules, like enumerative induction. He tells us on page 64, a rule is amended if it yields an inference we are unwilling to accept. An inference is rejected if it violates a rule we are unwilling to amend. The process of justification is the delicate one of making mutual adjustments between rules and accepted inferences, and in the agreement achieved lies the only justification needed for either. So Goodman claims that we determine principles of inference by employing the method of reflective equilibrium. The method of reflective equilibrium consists of alternatively considering general principles and intuitions, thoughtful evaluations regarding individual cases to which the principles ought to apply. Agents adjust either principles or case evaluations until reaching a stable and acceptable level of coherence between principles and case evaluations, called reflective equilibrium. A stable and acceptable coherence requires consistency between cases. Schematically, the process looks like this. We start with inference principles. We apply those inference principles to generate predictions about individual cases. We compare those predictions from our inference principles about those individual cases to intuitions regarding those individual cases. If there is a conflict between the prediction of our rules and our intuition about what should be the case, then we try to adjust either the intuitions or the rules to create greater coherence. We assess our coherence after adjustment. If our coherence is inconsistent, then we return to our inference principles and begin again. If our coherence is sufficient, we've reached that equilibrium state, and now we have an acceptable set of rules, at least for the time being. Now, in the spirit of this model, Goodman presents us with a problematic case, a case, or really a class of cases, that seems to generate an intuition that runs contrary to the predictions of enumerative induction. Namely, why do some generalizations seem to gain support from observations of their instances, while other generalizations, covering the very same observed instances, do not gain support? So when one heats a gas in a confined area, the pressure increases. Hence, heating gas is associated with increases in pressure. An example of confirmation of a generalization by an instance. Groundskeeper Willie has red hair, is right-handed, has a squint, and is Scottish. Clearly all groundskeepers are right-handed, red-haired Scottish squinters. A case that seems to receive no confirmation from its instance. But what's the difference between them? If our intuitive verdicts on these cases concur with Goodman's, then we seem to have a set of intuitions about individual cases that conflict with the predictions of enumerative induction. Specifically, we have one case of a generalization that receives confirmation from one of its instances. But then we have another instance of a generalization that does not receive confirmation from one of its instances. How are we to deal with this problem? How are we to distinguish the former case from the latter? Well, on 73, Goodman tells us the difference is that in the former case, the hypothesis is a law-like statement, while in the latter case, the hypothesis is merely a contingent or accidental generality. Only a statement that is law-like, regardless of its truth or falsity or its scientific importance, is capable of receiving confirmation from an instance of it. So let's be clear what's happening at this point. Goodman is suggesting that we do not modify our intuitive judgments about the cases, but instead we modify our rules. We modify enumerative induction, saying that it applies only to law-like statements, and we introduce a new rule to differentiate generalizations that are law-like from generalizations that are contingent or accidental in nature. What these cases illustrate, then, is that our current rules about induction, specifically that instances of generalizations always confirm those generalizations in proportion to their number, yield a result that we find unintuitive. Goodman suggests that we need to modify our rules. Specifically, we need to modify them so that only law-like generalizations receive confirmation from their instances. Now, you might suppose that this doesn't seem like that big of a problem, that the groundskeeper generalization isn't going to be confirmed very, very long. We'll run into all sorts of exceptions to that rule quite quickly. But Goodman doesn't think it's as easy as that to distinguish law-like from accidental or contingent generalizations. Observe how quote-unquote laws with alternative terms could also be as well supported by large bodies of observations as the ones that we choose. Consider emeralds. If we observe many, many emeralds over a very long period of time, we may formulate the generalization, all emeralds are green. But an alternative formulation of an alternative generalization would be just as well confirmed by all our observations to that point, namely, all emeralds are grue, where grue means green before Wallace's students finish their final exams and blue after. Now, specifically, Goodman defines grue in his chapter as follows. It is the predicate grue, and it applies to all things examined before T, just in case they are green, but to other things, just in case they are blue. As Goodman sees it, the problem posed by the grue case is that while one appears to easily make distinctions between law-like and accidental or contingent generalizations, upon reflection one realizes that one has no readily available criteria, that is, any rule for determining law-likeness. It might seem as if a modicum of effort could easily produce a solution, but Goodman tells us he disagrees. In the next lecture module, we'll see that Goodman reviews a number of different possible solutions to this dilemma, rejecting each in turn, after which he reformulates the problem to reflect what he thinks is the real nature of the difficulty.